What if the moon started getting closer to Earth? Imagine this. One night, you glance up at the sky and something feels off. The moon looks just a little bigger than usual. Not enough to panic, just enough to notice. The next night, it's closer still. And the night after that, it's massive. Let's say, for whatever reason, maybe a cosmic glitch, a gravitational hiccup, or an angry space wizard. The moon begins to spiral slowly toward Earth, not crashing down instantly, but inching closer each day. At first, it's beautiful. And then, it's deadly. The moon controls our tides through its gravitational pull. Normally, the average tidal range, the difference between high and low tide, is about 1 meter on open coasts. But as the moon creeps closer, that gravitational pull gets stronger. Really fast. Let's say the moon halves its current distance. That might not sound too dramatic, but gravitational force increases with the inverse square of the distance. So cutting the distance in half quadruples the gravitational pull. And tidal forces go up even faster, roughly by the inverse cube. Result: tides don't just rise, they explode. Coastal cities get slammed twice a day with floods the size of tsunamis. Boats get pulled out of harbors. Waterfronts vanish. Entire populations living near the coast. Billions of people are displaced or wiped out. But that's just the warm-up. As the moon draws closer, the tidal stretching doesn't stop at water. It starts tugging at Earth's crust, too. This is called tidal heating, and it's the same process that makes some of Jupiter's and Saturn's moons so volcanically active. In our case, the entire planet becomes a giant tectonic stress ball. Earthquakes become constant. Not occasional tremors, but daily ground-ripping quakes as tectonic plates warp under pressure. Volcanoes, dormant for centuries, suddenly awaken. Geysers of ash and lava spew across continents. Cities far from the coast, even deep inland, begin to crumble. The moon doesn't just bring floods anymore. Now, it brings fire. The moon starts entering low Earth orbit, a region where satellites usually hang out. But, unlike silent satellites, this moon is huge, fast, and messy. It begins to graze the upper atmosphere, compressing air layers beneath it. This causes rapid changes in air pressure, creating super hurricanes and shockwave winds that circle the planet. Air friction heats the moon's surface. It glows red hot. Parts of it begin to melt. Chunks break off, falling to Earth like meteors. Meanwhile, Earth's weather systems collapse. Jet streams shift. Rain stops in some places, while others flood. The sky turns brownish-orange from dust and ash. The sun becomes a dim circle behind a veil of smoke and panic. Now the moon is just dozens of kilometers above Earth. It appears 10 times the size of the sun in the sky. It's no longer just an orb. It's a looming ceiling. The gravitational force is so strong that the moon starts tearing itself apart from tidal stress, forming a ring of debris like Saturn S. But these fragments don't stay up forever. Some fall back to Earth, sparking continent-wide firestorms. Meanwhile, Earth itself begins to warp. Oceans rise and bulge toward the moon. Mountains crumble. Skyscrapers lean as the crust stretches unnaturally. GPS systems fail. Magnetic fields destabilize. Satellites fall out of orbit. The atmosphere becomes so distorted it can't support aviation or satellites anymore. Then comes the final impact. Let's assume the moon reaches the point of no return. It crashes into Earth. The result would release more energy than the combined output of every nuclear weapon ever made, multiplied by millions. Specifically, it would unleash about 10 sup-29 sup greater than joules of energy. For comparison, the asteroid that killed the dinosaurs equals approximately 10 sup-23 sup greater than joules. This, 1 million times stronger. The crust would liquefy. The oceans would vaporize. The atmosphere would be stripped. Earth would become a glowing molten sphere of regret. Basically, game over. No? Well, probably not. The moon is gradually moving away from Earth, not toward it, about 3.8 centimeters per year thanks to tidal interactions. It used to be closer in the distant past, but it's been drifting away for billions of years. So unless physics takes a long vacation or someone builds a moon harpoon, we're safe. That said, a massive asteroid or rogue planet could theoretically send the moon off course. It's extremely unlikely, but not impossible. And if it ever did, you'd better enjoy the view while you can. Because the closer the moon gets, the less time we have to say goodbye.